free fall, and the acceleration due to gravity. All unsupported objects near the Earth's surface fall towards it with the same exact acceleration. This acceleration is the acceleration due to gravity, and it's denoted by g. G is equal to 9.8 meters per second squared. All objects, regardless of mass, accelerate downward towards the Earth at the same rate. Since the acceleration is downward, we will consider it a negative value. So A is equal to minus g, which is equal to minus 9.8 meters per second squared. So whenever you see g in an equation, always replace it with 9.8 meters per second squared. The sign of it comes from when you talk about the acceleration. Right here, so you can see this negative g. If you were to put a negative 9.8 in for g, then you'd get a positive acceleration, which would be incorrect because we're accelerating downwards. Let's throw an object like a ball in the upward direction with an initial velocity v0. So we're going to start here. Now in reality, we want to throw it straight up and have it come straight down on the same path because we're only working in one-dimensional motion here, but we've expanded it out like this so we can put more words there. So you throw it up and you want to know what happens to the velocity and acceleration as you're going up, what happens at the very top of your trajectory, and what happens when you go down, then finally what happens right before it lands. So here we go. The object is thrown up with an initial velocity v0. As it's going up, it slows down continually and it has a negative acceleration due to gravity, negative g, negative 9.8 meters per second squared. The velocity is up, the acceleration is down, so that means it's slowing down. At the very top, its velocity is 0. The acceleration still the same. Wherever you are in your trajectory, you have the negative g due to gravity. And why is your velocity 0? Well, on the left-hand side here, you're going up, so that's a positive velocity. On the right, you're going down. That's a negative velocity. So how do you get from plus to minus? You have to go through 0. On the way down, you're speeding up. This time, it's the same acceleration, but it's in the same direction as your velocity, so you speed up. And right before you hit the bottom, you have a negative velocity, but it's v0, negative v0, just like what you started with, just with an opposite sign. It has the same magnitude as what you began with. Plotting the velocity time graph, here's velocity. The first term is always the y-axis. Here's time. When you throw it straight up in the air, you have an initial velocity here, which is v0, that's positive. The velocity continues to decrease until you reach the very top, and at that time your velocity is 0. Then at the bottom, when you hit the ground again, you have the same magnitude as velocity as where you started. In this one it's 3 tick marks. It's just a negative 3. When you take the slope of this line, and again you'd have to put proper units here and instead of just 1, 2, 3, you will find the slope is negative 9.8 meters per second squared. That is the acceleration, which is minus g, because acceleration is delta v over delta t, which is also the slope of that line.